All right, guys, so this will be lesson 1 of a new unit, and we're gonna move through exponents and the exponential function. Basically, is going to be unit 3. It's not a very long unit. It may go into some financial stuff too, which will be kind of probably unit 4. The two are related a little bit. Okay, so the learning goal for today is to recall the power laws that you probably know or have worked with in the past. And that involves like being able to multiply and divide powers with the same base, which we will look at what that means. And then be able to convert negative exponents to positive exponents and evaluate an expression. Okay, so without further ado, let's just take a look here at some of our exponent laws. Okay, so when we have, first off, let's just identify what it means to have the same base. Okay, so the base is the bottom part or whatever is below the exponent. Okay, so in this case, it's x, and the actual question I've given you here, the base would be 2. Okay, and then separated is that they are multiplied together. Okay, so that also means multiplied. The little dot implies multiplication. Okay, so so as long as the bases are the same, you can apply these rules, but only if the bases are the same. Okay, so you'll see as we go through here how that works. Okay, so I'll show you how to navigate these in a way that kind of makes sense. Okay, so when multiplying powers with the same base, you keep the bases the same. Okay, and then add the exponent. Okay, and that's illustrated right here. Okay, so when you have x to the m multiplied by x to the n, you simply add the two exponents together. So let's take a look at the example that's here. We've got 2 to the exponent 3 multiplied by 2 to the exponent 2. Well, that's just going to turn into 2 to the 3 plus 2, which equals the 2 to the 5, which you could evaluate on your calculator as being, I believe, 32. Okay, so the difference between these questions, okay, so it's 32. Okay, so the difference between these questions is you could say simplify the expression. So simplify, if it had said just simplify, you would have stopped here. Okay, if it says simplify and evaluate, then you have to tell me what the answer is. If it says evaluate, okay. So that'll be the difference and the distinction in what we're doing. Okay, so sometimes you can't evaluate, but you can fully simplify. You'll see a couple of different examples as we move through here. Okay, so when dividing the powers, okay, so this is the law of division, or we could call it quotient. Okay, sorry, it's just the law of exponents for division. Okay, so what happens is when we're dividing powers with the same base, we're again going to keep the bases the same, and then this time we're going to subtract the exponents. Okay, so you can see here I have the x's, x to the m divided by x to the n, and you can see I'm going to subtract, and so I'm going to get 2 to the 5 minus 3, which is equal to 2 to the 2, and 2 squared we know is 4. Okay, so the next one is law of powers. Okay, so when raising a power to an exponent, okay, so that's basically just saying when I have an exponent raised to another exponent, okay, we're just going to keep the base, Same as always. A lot of the time, like most of the time, we're just going to keep the base. Right? If it's the same, we're not going to want to change it. Okay. So we're going to keep the base and then multiply. Okay. And so you can see here, x to the power of m all to the power of n, you're going to multiply it. Okay, so m times n. So in this case here, we're going to have 2 to the exponent of 4 multiplied by 2, which is going to be 2 to the 8, which you could evaluate by putting it into your calculator. Okay, so you go to some of the phone calculators have kind of this XY notion. If you turn it sideways, it'll be x to the exponent y. So if you hit that button, it will then prompt you to hit whatever exponent you want. It will spit out the answer. Okay, so it's be 256. Okay. So law of exponents for products. Okay. So when a product is raised to an exponent, okay, so this is very similar. It's very similar in the way that it's going to happen here. Okay, so again, we're going to keep the bases, right? Each one of them individually, but we're going to apply this time what that exponent is to all the bases. Okay, so you can see here I have 2 different bases, right? I have an x and I have a y, okay? And then that exponent, n, is being applied to both of them. Okay, so for this question here, I have 3 different, what we'll call bases, right? I have a number, right? I have a number, I have x's, and I have y's. Okay, and this 3 is going to go to all 3 of them. Okay, but how does that work? Well, you can pretend that on each one of these there is a 1. Okay, or sorry, on the last one there's a 2. Okay, and basically what's going to happen is you're right back up here with this example, right? I have exponents raised to exponents, which I know I need to multiply. So my answer here is going to be 3, 1 times 3, x, and these are all multiplied together, x to the 1 times 3, and then I'm going to have y to the 2 times 3, right? Which is going to equal 3 cubed x cubed y 6, right? And then your final answer here, if I said fully simplify, you could write your final answer as being 27 x cubed y 6. Okay, and that's because 3 cubed is 27. Okay, so let's take a look at the next one. It's very similar, right? So law of quotients is the exponent. Okay, we need to take whatever that exponent is and apply it to everything inside of the bracket, right? So that just simply means apply the exponent to both the numerator okay, and you can see how that works here, right? So you see I'm applying the n to both, right? And so for here, I'm going to get 3 to the power of 4 divided by 2 to the power of 4, right? Which you could evaluate as being 3 to the power of 4 is going to be 27 times 3, right? Or you could go to your calculator and go 3xy to the power of 4, which is 81. And then it's going to be divided by 2 to the power of 4, 16. And if you could reduce that further if you needed to. I don't think it is. But that would be your final answer if I said simplify as well. Right? This would be simplify. This is evaluate. Okay. So last two. Okay, so 0 exponent. This is an easy one. Anything to the power of 0 always equals 1. Right? So x to the power of 0 is equal to 1. This number to the exponent 0, 1. Easy one. Okay, don't forget about that one. And then integral exponents. Okay, so when evaluating a power with a negative exponent, okay, you're going to take the reciprocal of the base. Okay, so that's just simply meaning if I had x to the negative n, the reciprocal just simply means that it becomes the opposite in terms of the fraction. So the x to the power of n moves to the denominator with a positive exponent. Okay, so so you can see here, okay, this is just going to simply become 1 over 5 to the 2, which is going to equal 1 over 25, okay? And then you can see here if I did what's going on here, I can show one more step here, is I'm applying a few different power laws or exponent laws within one particular question, right? So for this one, what I would have done is taken the negative n and applied it to both the numerator and denominator. So I would have done this first. So x to the negative n over y to the negative n, which I could then therefore, because both of these are negative, I could flip them and make them positive. So it would be y to the n over x to the n. That's how I arrive here. Okay, so similar question here is I'm going to do 4 to the negative 2 divided by 3 to the negative 2, which is then therefore going to become 3 squared over 4 squared, which is going to equal 9 over 16. Okay. So what I'll do is take a break from here, and then I will create a separate video for the actual questions that we can actually do. Okay.